Hello, welcome back. Today we'll discuss what recursive language models are. Have you ever noticed that even the smartest AI eventually becomes, well, kind of an idiot? You are working on a massive project, you have fed it 50 files, you are deep in the zone, and then suddenly it forgot the very first instruction you gave it 10 minutes ago. In the industry, we call this hitting the context wall. Standard AI models are like someone trying to read a book by holding every single page open in their hands at the same time. Eventually, they run out of hands, they run out of memory, and the whole thing collapses. But what if the AI didn't have to hold the pages? What if instead of just reading, it actually organized the information as it went? What if it built a mental map, a hierarchy, or a pyramid of thought that allowed it to remember the beginning of a multi million token document as clearly as the last sentence it just typed? This is what exactly a recursive language model does. It's not a bigger brain, it's a better way of thinking. Today, we are going to step past the hype of biggest context windows and look at the actual engineering that allows AI to finally have a long term memory that actually works. In the next few minutes, we'll break down exactly how RLM work. To make this easy to follow, we'll do this in a simple question answer format. Each question unpacking one layer of the system step by step. So let's start with the most basic question of what is a recursive language model? Technically speaking, an RLM is an architecture that treats information as a hierarchy rather than a sequence. Instead of just sliding a window over text, it takes a block of data, compresses it into high dimensional vector, and then feeds that vector back into the model as an input for the next block. It's essentially a folding mechanism. The model creates a parent node that represents the semantic essence of a group of child nodes. It does this over and over, building a tree where the top nodes represent the global context of the entire document. In a standard transformer, the cost of looking back grows very quickly. In a recursive language model, that cost is flattened because the model isn't looking back at every word, it's looking at its own refined, recursive summary of those words. It's moving from raw pattern matching to a structural navigation. Now, why does a recursive language model exist at a first place? So, if you use GPT or Claude, you know they eventually start to forget the beginning of a long conversation. This happens because of the attention mechanism. In a standard transformer, every new word has to look back at previous word. If you have a million words, then that's a trillion connections to track. It's a math nightmare that eats up all the memory on a chip. We build recursive models because we hit a wall. We needed a way to give AI a long term memory that doesn't grow exponentially. We needed a way to process a whole library without needing a supercomputer to remember the first chapter. Now, let's come and see what are the common misconceptions about the recursive language models. A lot of people hear the word recursive and think of the old RNNs from 10 years ago. They think we are just going back to the old way of doing things, where the model processes one word at a time in a loop. But that's not true. And the big mistake is thinking the model is just summarizing the text like a TLDR bot. It's much deeper than that. An RLM isn't just shortening text, it's encoding the logic of the text into a different format. It's not losing the data, it's just changing how the data is stored so it can be accessed instantly without rereading the whole thing. Now let's come and have a look about the high level architecture of the language recursive mode. So think of the architecture like a corporate hierarchy. At the bottom, you have the workers, there are raw tokens, the actual words. Above them, you have managers, these are the nodes that represent a group of words. Above them, directors, and so on. When the model wants to find a specific piece of information, it doesn't talk to every worker. It asks a director, who asks a manager, who points to the right worker. This tree based structure allows the model to jump to the exact part of the data it needs. It uses layer of compression to turn a massive horizontal string of text into a vertical tower of meaning. So, what signals or input does a recursive language model observe? The model starts with the same stuff every AI does, raw text. But as it moves up the recursive chain, the input change. It starts observing latent informations. These are basically math vectors that describe the vibe or the point of a paragraph. It also looks at the structural signals. It notices things like this is a header or this is a concluding sentence. By paying attention to these landmarks, the model can decide how to compress the information. It's looking for the skeleton of the information, not just the skin. So, how does recursive language model understand context? Standard models have a window, they look back. If the window is 10,000 words wide, they see 10,000 words. RLM don't really have a window, they have a zoom lens. To understand the context of a page 500, the model looks at the compressed manager notes of the previous 499 pages. It's like knowing the plot of a movie because you saw the trailer and the chapter titles. Even if you weren't focused on every single frame, it maintains a good global state that is updated every time it processes a new block of text. So the context is always present, just in a highly distant form. So, what is the hardest technical problem in recursive language models? The biggest headache is lossy compression. Imagine making a photocopy of a photocopy. Eventually, the image gets blurry. In an RLM, if the model summarizes a paragraph poorly, that error gets carried up to the next level. If that happens 3 or 4 times, the directed node at the top of the pyramid might have a totally wrong idea of what the book is all about. Keeping the compression lossless or at least highly fidelity, it's a holy grail. We also struggle with the backpropagation through time, which is just a fancy way of saying it's really hard to train these models because the math loops back on itself and can break the training process. So, how does a recursive model scale? This is where it's get exciting. In a normal AI, if you double the text, you quadruple the work. In a recursive model, if you double the text, you only add a little bit of more work, logarithmically speaking. Because it organizes data into a tree, it scales beautifully. It can handle massive data sets because it only has to activate the part in a tree that matters for the current question. It's like a library. Adding more books doesn't make it harder to find one book as long as your filing system, the recursion is solid. So, what are the failure modes of a recursive language model? The most common way these fail is semantic drift. The model starts talking about a topic, and because it's relying on a compressed memory, it slowly drifts away from the fact. It's like the game of telephone. Another failure is overgeneralization. If you ask a specific question about a tiny detail on page 42, the model might give you a vague, high level answer because it compressed that specific detail out of existence. It knows the vibe of page 42 but forgot the specific date or name mentioned there. So, what are the different alternatives and how it is actually different from its alternatives? So, you might have heard of RAG, retrieval augmented generation. RAG is like having a robot that runs to the library, grab the 3 books, and brings them to you. It's fast, but the robot doesn't understand the whole library. It just needs and finds the keywords. RLM are different because the understanding is baked into the model structure. It's like retrieving a snippet. It's remembering a structure compared to things like Mamba or state space models, which are a continuous stream. RLMs are more like a structured map. They handle hierarchy much better than a simple stream does. So, what is the real innovation behind the recursive language models? So, the real aha moment here is the move away from next token prediction. We have spent years making models that are great at guessing the next word. RLMs are the first step toward model that guess the next thought or the next concept. The innovation is the hierarchical latent space. It's the idea that information isn't just a flat line, it's a multi-layered building. But teaching an AI to build that building as it reads, we are giving it a way to actually reason over long form logic rather than just mimicking patterns. So, the final one, what will recursive language model look like in the future? In a few years, the idea of context limit will be a joke. You will be able to feed an AI every legal document ever written in the history of the world. And because it's recursive, it will digest that information into a permanent structural memory. We will see agentic reading, where the model recursively explores a code base to fix a bug, zooming in and out at different levels of abstraction perfectly. We are moving toward a world where AI doesn't just have a better memory but a better sense of scale. And that starts with recursion. So that's all I have for today. Thanks for watching.